Tokenization is one of the fundamental processes in large language model and generative AI. Tokenization is the process of splitting the input and output text into smaller units that can be processed by the large language models in AI. Tokenization breaks down vast amount of text into more digestible and understandable units for machines. The primary objective of tokenization is to represent text in a manner that's meaningful machines without losing its context. On a very high level, that representation of text is in numerical vector format, which is also called as embedding. There are a lot of tokenizers out there which perform it in different ways, and this has been evolving over the period of time. Traditional simple rule-based tokenizers, which are from the past, divide text into words using spaces and punctuation. They were quite commonly used until like 1 year ago, but now they are not used that much because of a one major limitation. The limitation is that they cannot recognize any new words into the vocabulary. They know only what they already know. If you introduce any new word, then they won't be able to recognize it. For example, there are a lot of new words which even as of today get added into languages like English. Like few years ago, we added a new word selfie, and there are a lot of them. But if we are using those simple rule-based tokenizers, the LLM won't be able to recognize that word. These unknown words are called as out of vocabulary tokens or OOV tokens. These out of vocabulary tokens get mapped to a single special token, losing its distinct information. So what happens behind the scene is that these OOVs are represented by same embedding. In this video, I'm going to introduce you to Spacy, which uses a rule-based tokenizer and deals with these out-of-value tokens. I will also drop the link in this video's description where you can read more about the tokenizer from Spacy, as there are a lot of information out there. But let me show you a running example in Google Colab as how this works. So I'm already logged into my Google Colab, and you can simply go and to colab.google to access it out. It's free. I have already selected this T4 GPU. Let me show you quickly and change runtime type so you can see I already have this T4 GPU saved. Okay. Now the first step we need to do in order to use Spacy is to install it. Let me use the command. So you can install it by simply pip, and I'm also upgrading setup tools wheel and also Spacy because Spacy comes pre-installed with Google Colab, but I'm upgrading it. Let's wait for it to finish. Shouldn't take too long because it is upgrading it. So for first it is uninstalling it and then it is going to upgrade it. That is fine. Let it run and then we will restart the runtime so that it will take effect. That's done. Cool. Let's come down. That is nice. Okay. Now in the next step we are going to download this Encore WebLG. This model, Encore WebLG, is the largest English model of Spacy with size around 788 MB, and it is an English language multitask convolutional neural network or CNN, which has been trained on onto nodes. What it does is it assigns context-specific token vectors, POS tags, dependency pairs, and named entities. So let's download it. Let's wait for it to finish. Shouldn't take too long. Model has been downloaded here, and you can ignore this warning. That is fine. Now let me show you the code. Okay, so in this code, which I'm going to paste on the screen in this cell, this shows us how this Encore WebLG works with Spacy. First, we are importing the Spacy and NumPy. Then we are loading this model which we have just downloaded. After loading this model, this is the text we are passing to this model. So as you can see in this sentence, there are two new words. One is this new word in vocab, and then this is jugaad, which is another. It is common Urdu Hindi word, but it doesn't belong to English. So it's a new word for English. Model wouldn't know about it. Spacy should be able to recognize these two words and then create embeddings on it, which should be the same number because out of vocabulary words we are representing with same numerical representation. Then we are passing this to Spacy model and generating the vector or numerical representation or embedding. And then we are extracting those OV tokens and printing the size and the tokens here. Let's see if it is able to recognize these two words and create a numerical representation. So let's run it. There you go. So it was able to recognize this out of vocabulary words, both of them, and then there's the same number for both of these OOV values. So this is how Spacy works, and there are a lot of other tokenizers out there, and I'll be doing more videos on them. But this video was more focused on this Spacy. I hope that you enjoyed it. If you have any questions or feedback, please let me know and put it in the comments. And if you like the content, please consider subscribing to the channel. Thank you.